Okay, we're going to begin a discussion now on the number of roots that you could expect in a quadratic equation. If we think about a quadratic graph, there are three possibilities that you could have for the number of roots. You may have the graph cut through the x-axis in two places, so it could either point up or point down. And in this case, or case is shown here, you'd have two roots, either one is pointing up or pointing down. So to keep track of this, you could have two roots, or x-intercepts, or zeros, all referred to as the same. Now, another possibility, you may have the graph come up, hit the x-axis at one point, and have one root, or one x-intercept. And the last possibility, perhaps the graph never touched the x-axis at all. Maybe the graph would look like this. And here, there's no way possible the graph could intersect the x-axis, or the graph may look like that. And in that case, there will be zero roots. And remember that roots, zeros, and x-intercepts all mean the same. Okay, so big question of this now for you folks is, how do you find out this information without graphing? So the question we need to answer, how do you determine number of roots without graphing? Because graphing can obviously give it to you. You would see it as in here. But we need to have a written method of doing it, so without graphing. And how we're going to solve this comes into our quadratic function, our quadratic equation that we've already went into before. And just a refresher, quadratic equation. Let me see. Negative b. Let me fix that. Negative b plus or minus b squared subtract 4ac all divided by 2a. And I haven't forgotten it. You have to take the square root. Now this is the formula used for finding the number of roots. And we could use this we could plug our numbers in and find out the number of roots that we had. But there's a quicker way of finding out how many roots we have without actually having to finding out what they are. So again, this formula would tell you what your roots are. So this formula will tell you what the roots are. But we don't want, let's say you don't really care what the roots are. You only want to know, are there 0 roots, 1 root, or 2? So that's your question. But you don't need to go through all this. There's a shorter way to do it. And a shortcut you could take is by doing just this calculation here. That would let you know. Now, what we're going to do here, when you put your numbers into the equation there, this b squared subtract 4ac, if your answer works out to, there's 3 types of answers you're going to get. Your answers, so I said there's 3 types of answers. Let me just do this. So you could get this number, this value, and in case you didn't know, this value is called the discriminant. It's just a name put on that. So if this discriminant works out to be equal to 0, there is one root. And what that would mean is that the graph touches the x-axis at one place. If the value is bigger than 0, there are two roots. So you may get a case like this, but either way, the graph cuts through at two places. And if the value is less than 0, in other words, if it's negative, you would have this case, where the graph does not cut through the x-axis. So here there are no roots. And next video we'll do a couple questions now surrounding this. We'll carry out more examples.